All right, guys, good morning. Hey, today, guys, we're going to look at covalent bonding. We're going to look at how to name covalent compounds, and we're going to look at how to write the formula for covalent compounds. All right, first of all, we need to recall what an ionic compound is and compare it with what you call covalent compounds. So let's look back. So, first of all, let's talk about ionic compounds. All right. Remember, guys, when we talk about ionic compounds, okay, the bond between them is called an ionic bond. So again, an ionic bond. All right. What's so specific about this bond is there is a transfer of electrons. So for ionic bonds, you have a transfer of electrons. Okay. All right. So you got transfer of electrons. So remember, how does this electron transfer? Where does the electron come from? Remember, guys, in ionic bond, you always have a metal, okay, and a non-metal. Okay. In our case, it's the metal that loses the electron, which becomes positive. Remember, this becomes a cation. And the non-metal is the one that takes the electron, so this becomes a negative. So essentially what you have here is the electron going from the metal, okay, to the non-metal. All right. So there is a transfer of electron. Right. All right. So again, the metal, remember, metals, they don't like electrons, so they tend to lose them. Non-metals, on the other hand, they want electrons and they try to grab those electrons right there. All right. Now, how about covalent compounds? Well, covalent compounds, guys, are made up of both non-metals. All right. So, and we already know that non-metals both want electrons, right? So you have two non-metals and they both want that electron. So what happens is there's no transfer of electrons, there's a sharing of electrons. All right. So again, there won't be a transfer of electrons, there's going to be a sharing of electrons. All right. So we'll focus more about this when we go look at Lewis dot diagrams. But for now, let's focus on the name. So how different is the naming process from ionic compounds to covalent compounds. All right. Oh, by the way, when we talk about covalent compounds, guys, it's not really, we don't say most of the time a compound, we say it's a molecule. All right. So, molecule. Covalent compounds are technically what you call molecules. All right. So, let's look at the naming process. Okay. Remember, in ionic compound, we just name the cation first, followed by the anion, ending it with IDE. All right. Naming covalent compounds is almost the same thing. But this time, guys, you have to put in the number for each element. How many of each element do you have? Okay. So the naming process is right here. So we name the first element. Okay. But before that, we have to put the prefix. Okay. That tells you how many of that first element is. Okay. Name the second element, end it with IDE, but again, you have to put a prefix that tells you how many there are for that element. Again, it's called the prefix because it comes before the word. All right, let's take an example. Oh, by the way, the list of prefixes, they're all here. Okay, so one is mono, two is di, three is tri, four is tetra, five is penta, six hexa, seven hepta, eight octa, nine nona, and 10 deca. All right, let's talk about, for example, CO2. Okay, if you look closely, our first element in CO2 is carbon. All right, you see it? And how many carbons do you have? One. One. All right. Okay, but wait a minute. Since we're putting in names, we can't just, write down the number one. So we have to replace that one with a prefix. So this is, look at the table. One is mono. So instead of writing down one, I'm going to write down mono. All right. Let's look at our second element. Our second element is oxygen. Okay. But if you look at the naming process, we have to end it with IDE. Okay. So again, let's change that to IDE. So this is IDE. And how many oxygens do we have? If you look closely, we have two. But again, guys, you can't have a number there because it's a name. So we have to actually write down the word for two, and the prefix for two is di. So this will be changed to di. All right. So let's polish this up and let's make it fancy. All right. So if you look closely, guys, the name should be mono, okay, carbon. But wait a minute. Let's look at our naming convention. Again, you write down the prefix except mono, so you don't write mono on the first one. So you never write mono on the first element. Okay. So it's just carbon, space, okay, di for the prefix, and then oxygen, OX, and it with IDE. Okay, so the name of this thing is, let's write it down properly, capital C, carbon, space, dioxide. All right, if you notice, guys, I capitalized D. Okay, if we follow formal naming conventions, the first letter of each part of the name should be capitalized, but again, the naming convention has changed since when I was younger. So you can actually write it down this way, carbon space, and then it's not capitalized, dioxide. See it? All right, let's try it out again. All right, let's erase that and let's try it out again. For example, look at this one right here. Okay, so this one is PCl3. All right, so let's write it down. So what's our first element again? Phosphorus. Okay, be careful of the spelling for phosphorus. Sometimes it's ROUS, but we just spell it RUS. How many phosphorus atoms do I have? One, but again, you can't have a number, so we have to replace it with the prefix mono. But look, according to the rule, except mono, you don't write down mono for the first one, so erase that again. So there's no mono. Okay. All right, let's look at our second element. Our second element is chlorine. But remember, you have to change the last part to IDE. So I'm going to change that to IDE. I get chloride. And how many chlorines do we have? We got 3. But again, you can't have numbers there, so we have to change it to this. So it's tri. See it? So the correct name for this thing is phosphorus. Okay. Space trichloride. See it? All right. Cool. Let's try out another one. All right. So ignore this one right at the bottom. So let's try, for example, C, big C, and big O. I can clearly see, by the way, guys, that I have 2 elements. Okay. Which means I followed the naming convention. I named the first element first. And what is that? It's carbon. Again, how many carbons do I have? 1. But again, you can't have a number. So let's erase that number and replace it with a prefix. It's supposed to be mono. But look, again, the rule states except mono. So I don't put mono. So I erase that mono again. So it's just carbon. Okay, our second element is oxygen. But again, it has to end in IDE. So it's oxide. And how many do I have? 1. Okay, but again, you can't have a number. Erase that. So it's supposed to be mono. Okay, now look. For the second element, you have to write down the mono. For the second element, you have to write down the word mono. All right. So that's a complete name. So let's polish this up. So capital C, carbon. And in space, the second name is monoxide. All right. Let's stop here for a second. Guys, you see the O and the O between mono and oxide? All right. If you have 2 vowels, and most of the time this is between O and O, or A and O, okay? If you have O and O, A and O in succession, most of the time we cancel one of the O's or one of the or the A to make it sound nicer. And again, this is just a funny rule that they have. So again, if you have 2 vowels, O and O or A and O, you cancel the A or the O to make it sound nicer. So instead of writing down carbon monoxide, we cancel out one of the O's and we just report it as carbon monoxide. And that's the name of this thing, carbon monoxide. You see it? All right. So look, guys, we've been naming compounds that has 2 different elements. Now, what if the covalent compound has only 1 one type of element. So for example, let's say you have N2. Okay, let's say you have N2. Guys, clearly you only have one element here. If you look closely, there's only one element, right? All right. So how do we name this? Is this the first element? So N, nitrogen. Is that the first element? Is it the second element? And do we put in prefixes? All right. If we follow the rule and you say this is the first element, so this should be nitrogen. Okay. And again, since I have two nitrogens, this is supposed to be dinitrogen, right? Well, there's a funny rule about this as well. If you only have one element, so let's write that down. So the funny rule is if you have only one element, okay, just use the original name. All right. So we just use the original name. So instead of writing down dinitride or dinitrogen, the name of this thing is simply nitrogen. Okay, nitrogen. Okay, and most of the time they add the word gas after it. Okay, so another example. Ignore this one. For example, guys, H2. Again, I can clearly see there's only one element there. So the name of this thing is not dihydrogen or not dihydride. It's simply hydrogen. And you can actually add the word gas to it. Okay, you don't have to if you don't want to. You can. The name is simply hydrogen. All right. For example, guys, neon, Ne. Okay. Oh, by the way, I know this is still covalent compounds because these are still all non-metals. All right. So Ne. So this is just neon. And again, you can add the word gas, but you don't have to. So neon gas. See it? All right. Hopefully you learned that. Okay, cool. Let's reverse it. So this time, guys, what if you're given the formula, given the name and you want to find the formula, all right? So you can do all these exercises in the slides, all right? So what if, guys, you're given now the name, okay, and you just want to write down the formula. For example, nitrogen dioxide. So let's do this one right here. So nitrogen dioxide. So what is nitrogen? Okay, by the way, if you look closely, this should have been capitalized, all right? Okay, nitrogen dioxide. Nitrogen is N, right? How many nitrogens do I have? Since there's no prefix, we assume it's one. Again, you put the number behind the symbol. Okay, in prefixes, you put it before. Here, numbers go after, and they're all subscripts. But wait a minute. One is invisible, so you don't have to write it down. Okay, right. What is the next element? Oxide is oxygen. And how many oxygens do I have? The prefix di, if you look closely at the list, means two. So therefore, this is two. So this one, nitrogen dioxide, is NO2. You see it? Okay, let's try out another one. Okay, for example, diphosphorus pentoxide. All right. Diphosphorus. So what's the first element here? Phosphorus. And what's the symbol for phosphorus? P. How many P's do I have? Again, the prefix in front tells you di means two. So therefore it's P2. Okay, what's the second element? Pentoxide. Oxide is your second element. So O. And how many O's do I have? Pent. Okay, wait a minute. It's missing an A. Yeah, remember we cancel out A and O. If you have an A and O side by side or O and O, you cancel the A or the O to make it sound nicer. So in our case, penta is our prefix, so therefore it's a 5. So diphosphorus pentoxide is P2O5. See it? All right. Okay, let's try another one. Okay, xenon tetrafluoride. Okay, you all look. So again, same process. Xenon is what? Xe. How many Xe's do I have? There's no prefix, so we assume it's 1. Okay. Fluoride is your next element. It's F. And how many fluorides do I have? Tetra is our prefix, and that's a 4. So this is simply XeF4. See it? All right. Let's try this one right here. Okay, for example, guys, it's argon. Okay, wait a minute. Or some people would write this down as argon gas. Okay, so we just want to focus on argon. All right, argon. If you look at the periodic table, that's only one element, Ar. Okay, so what will be the formula? It's just Ar. Okay, if it comes from a, guys, if it comes from the noble gas column, all right, if it comes from the noble gas group or family, just write down the symbol and that's it, Ar. See it? So argon, guys, is simply Ar. Okay. But what if it doesn't come from the noble gas section? For example, guys, let's say nitrogen. Okay. And again, most of the time people write down the word gas. You don't have to, but nitrogen. All right. So, guys, if you look closely, nitrogen, again, there's only one element here, N. The question is that the answer? No, it's not. Guys, if the element comes from the noble gases, you just use the symbol. But if it comes from somewhere else, if the non-metal comes from somewhere else other than noble gases, you must put a 2 after it because it's a diatomic molecule. You got it? So, what are those diatomic molecules? Let's make this a lot clearer. Right. So, look, let me give you some examples so you can clearly see it. So, for example, guys, I'm going to give you several ones. All right. Neon. Okay. Argon. Xenon. Helium. All right. And don't forget, guys, most of the time people would write this down with the word gas after. Okay. Gas. Okay. Gas. Gas. All right. So, all right. So, for example, guys, neon gas, argon gas, xenon gas. All right. If you all notice, this just all of them, they all belong to group 18 or the noble gases. All right. So, again, if it's group 18, they all belong to noble gases. You just use the symbol for the original element. Again, there's only one element here, and you can clearly see it. There's only one name. So, this is just Ne. That's just the formula. Argon gas, Ar. Okay. Xenon gas, Xe, right? Helium, He, right? On the other hand, guys, if it's not in group 18, if it's not in group 18, for example, let's say hydrogen, okay? Hydrogen, and we're talking about the molecule, the hydrogen molecule, all right? So again, let's talk about the hydrogen molecule, or let's take, for example, the fluorine molecule, right? Okay, or let's say the chlorine molecule, or the bromine molecule, okay? Or the nitrogen molecule, that's an N by the way, nitrogen molecule. Or oxygen molecule. Okay, these are all molecules, don't forget. And most of the time, people would put the word gas after it. Okay, and again, you don't have to, as long as we all understand that these are all molecules, not the element itself, but the actual molecule. Okay, so you can put there the word gas or molecule, it doesn't really matter. But if you look closely, guys, none of these belong to group 18. And you, when you write down the formula, guys, you have to actually write down 2 afterwards. So hydrogen gas is not just H, it's H2. Okay. Fluorine gas is not just F, it's F2. Okay. Chlorine gas is not just Cl, it's Cl2. Bromine gas is not just Br, it's Br2. Nitrogen gas is not just N, it's N2. And oxygen gas is O2. Remember, guys, these are called diatomic molecules. Okay, diatomic molecules. They're called such because there's 2 atoms. That's why it's diatomic molecules, right? But for everything else, guys, you follow exactly the same formula writing convention, right? You just uh, reverse it, look at the prefixes, and they become subscripts that follow the symbol, chemical symbol for that element. All right. So again, and don't forget, if it comes from group 18 and you only have one element, just use the symbol without any numbers. If it's an element, if there's only one element and it's not from group 18, you have to put a 2 behind it because it's a diatomic molecule. All right. Hopefully, you learned something today. Again, guys, look at the examples, try the examples out. All right. And if you need help, go ahead, tell me, and I'll help you out. All right.